Hello all of you. Now we are trying to discuss the complexity of algorithm. Now why we discuss complexity of algorithm? To discuss complexity of algorithm, we can specify the efficiency of an algorithm. How to judge an efficiency of algorithm? Suppose here in all text we take that M is an algorithm and N is the input data. This input data decide the performance of an algorithm. We can measure it in a two way, time complexity and space complexity. Complexity of algorithm depends on the time it taken to perform all the steps of an algorithm and the space which taken by all the variable and constants of an algorithm. There are three types of case analysis we can perform for this analysis: the best case analysis, the worst case analysis and a average case analysis. For this purpose, we take a simple linear search algorithm in which we can analyze these three cases. In a linear search algorithm, suppose we have one array of 10 integer elements and we need to search a value in this array. Like if we have a value which present at the starting of the array, then this will be a complexity in the case of best case algorithm. Like in each of the complexity algorithm, we have a function. In generalized way, we use a function in which we put some inputs and according to inputs it gives some outputs. In this best case analysis, when we put a value to search in an algorithm, this value if it present at the first stage, then it will use less space to store and the less space for time consumption. That's why it is known as best case analysis. So we write down the complexity as a function named C, input n and the output will be 0. Then second case analysis is worst case analysis. In this type, in case we have a value which present at the last element in the array or it may be not present in the array, then it will go till the last one element. That's why the answer of this function will be the n. N is the total number of element in array. And then the third one analysis is average case analysis. Average case analysis is expected of any searching algorithm. Like if we have a value, it can be present in any place of the array. Like it has some probability, it can be at first stage, it can be second stage, it can be third stage. So we can take a probability for all spaces and the probability for each and every spaces will be 1.1 upon n. So we take all the probability and add all the probability 1.1 upon n, 2.1 upon n, 3.1 upon n till n upon 1 upon n. And then we solve this equation and we find that the average case analysis, we find the output of this function is n plus 1 upon 2. So these are the three cases of analysis. And after that we analyze that some of the asymptotic notations we in this growth of function. Suppose a algorithm have some values for a generalized function. When we take a comparison of generalized function, it is known as a standard function. Here we show this standard function as general Gn. These function can be a simple log n log n square, n cube and 2n. These all functions are standard function. Whenever we want to test the complexity, we compare our algorithm with these all standard function. When we got a function which get a lower bound with our function, then it can be shown as the function n less than equal to, this is our algorithm and this is generalized function. This type of function analysis we can show as a big O notation. Why it is big O notation? Because it say the upper bound. The generalized function have upper bound with this function. It can show as a O Fn equal to O Gn. It specify Fn is order Gn. Second type of notation which we utilize in complexity is omega notation. It's somehow different from big O notation. It has the lower bound function. In standard function, it has lower bound with the function. It can be shown as Fn omega Gn. The value of Gn is lower bound with function. Fn greater than equal to mgn. For all the values as the input, this n is the input. As we have discussed in this section, n is input for the function. To example, complexity, where n is greater than equal to n0. This n0 is positive integer for analysis. And third one notation is theta notation. It's somehow different from big O and omega notation. The theta notation specify both types. It can be upper bound, it can be lower bound. That's why here we take two constants, one of C1 and second one is C2. This function here we can see the function in between and the general function perform both type. C1 is lesser than and C2 is greater than. It provides the both type. It can be upper bound and it can be lower bound. C1 is lower bound and C2 is upper bound. So all about the complexity, we have discussed three types of case analysis: best case, worst case and average case, and we have discussed three types of notation. For more details, log on to www.gurukpo.com.